Hey, welcome to day 2 of this performance testing with Apache JMeter session. Yesterday we discussed about software development lifecycle, software testing lifecycle, what are the basic categories under software testing lifecycle, difference between functional testing and non-functional testing, and what is performance testing and the definition. What are the why we need to go with the automation tools for performance testing, and what all are open source tools available in market, and what are the commercial tools available in market, and why testing is important. All these topics we covered in yesterday's session. So today we are going to cover what are the important types of performance testing, and we'll see a few performance testing terminologies and performance testing life cycle. Okay. Before
Hello, Ganesh. Your voice is not audible if you're speaking.
sorry, who is this?
It's audible now. I thought you were speaking and your voice was not audible. So I just prompted.
Uh, uh, no. Before starting today's session, if you guys have any questions in yesterday's session, please let me know. Otherwise, I will start today's topics. Okay. Let me start today's session. As I said yesterday, right? What is performance testing? Performance testing is a software testing methodology, and it is a non-functional testing which is used to measure the behavior of the system when multiple users are accessing the application or system. Okay, when we are telling behavior includes speed, stability, scalability, and resource usage. Okay, this is the performance testing definition, and yesterday we discussed. And in performance testing, there are a lot of subcategories under performance testing, and we have very important types of testing. For any project, most of the clients are expecting, right? We have 4 types of performance testing is very important. First one is load testing. Second one is stress testing. Third one is soak testing and spike testing. Apart from these, we have a lot other testings are there, but these are the main categories under performance testing. Okay, first we will see load testing. What is meant by load testing? So when any client come with the performance testing requirement to performance testing team, right? Uh, initially, we will ask them few requirements, we will call it as non-functional requirements. We will detailedly discuss in the next sessions, but for the time being, let's take a few things when a client come for the performance testing requirement, we will ask them the what is the maximum user load, what is the transactions per hour we need to achieve, right? Okay, so let's take a ticket booking website. So a client come up with a requirement he want a load performance testing for his application with 100 concurrent users, and he need to achieve 1000 transactions per hour. Here 1000 transaction per hour, in the sense his requirement is 100 users need to book 1000 tickets in 1 hour. Okay, this is his requirement. So uh, uh, as per his requirement, initially we will develop the automation scripts using JMeter script, and then we need to do the load test execution for the ticket booking business scenario with 100 concurrent users. So here 100 concurrent users is the maximum load he's expecting. Okay, So if you see this graph, so here, sorry, let me, so here requirement is 100 users need to achieve 1000 transactions per hour. Okay, here 1000 transactions per hour, in the sense you need to book 1000 tickets. Okay, so here we need to do a load testing with 100 users. Okay, 100 users in 1 hour. 100 users need to achieve 1000 transactions per hour in per hour is nothing but in 1 hour he need to book 1000 tickets. So each user need to book 10 tickets in 1 hour. So when we are designing the scenario, this horizontal line indicates the time. Okay, and this vertical line indicates users. Okay, so um, when we designing the scenario, the graph looks like this. So this is 100 and this is 5 minutes. This is 1 hour 5 minutes. So this first 5 minutes we will call it as ramp up. And this 1 hour we will call it as steady state. Okay, in today's session I will clearly explain you this stuff also. See, for 5 minutes slowly, all the 100 users will log into the application, and then those users will start booking tickets. Till after 1 hour, all the 1000 tickets will be booked, and after that, slowly users will ramp down. Okay. So load testing is nothing but validating the performance of the application under expected load. Here, expected load is 100 users. So when we do performance testing with 100 users, we will call that test as load test. Okay. Coming to stress test. Stress test is nothing but evaluating the performance of the application at the load much higher than the expected. So if application is able to handle the expected load, in our example the expected load is 100 users. So in testing, what we will do, we will gradually increase the load. First we will test with 150 users, then we will go with 200 users. If application is still stable, we will go with 250 users. Like that, we'll gradually increase the load in each iteration of the load test. And sometimes we may need, like a client asks us to find the breakpoint. Like likewise, we will slowly gradually increase with like 200, 300, 400. At what user load the system is breaking, we also do this kind of testing. You will call it as stress testing. And next we'll come to soak testing. Soak testing, soak testing is nothing but we'll call it as endurance and long duration test also. Like in few companies, like they will call it as soak test. A few companies they will call it as endurance test. A few companies they will call as duration. Some people they will call it as long duration. So soak testing is nothing but executing the load test with the expected load. Again, here we are testing the uh, application with 100 users, but for longer duration. Okay, that is the reason they are calling it as duration test. Let's say in our example, the client requirement is 100 users need to achieve 1000 transactions per hour, right? So in soak testing, what we will do, we will test the application with 100 users only, but the steady state will be more. I mean, in load testing, we are testing application for 1 hour. When it comes to soak testing, we will test it for 3 hours, 4 hours, 5 hours, 6 hours. If you are testing for 4 hours, the transaction per hour will be, again, transaction per hour will be 1000. But if you are running for four hours, each hour it will book 1000. 4 hours it will book 4000. Okay, so the main aim of soak testing is to uh, identify the memory issues. Let's say if application is able to handle 100 users successfully for 1 hour, if you run for 2 hours, maybe the resource utilization of the servers may vary. If we run for 4 hours, we'll came to know if there is any issues related to garbage collection or any other memory issues. This kind of issues we can identify easily with the help of soak testing. In few companies, they will do soak testing for 8 hours. In few companies, they will do for 12 hours continuously. If you see like the e-commerce sites, right, 24/7, those sites will be available. Like when sometimes they will announce sale for 3 to 4 days, right? So all these 3 to 4 days, there is very heavy traffic on these applications. So those kind of applications, definitely they will go with the soak testing. Okay, this is soak testing. And coming to next type, it is a spike testing. Spike testing is nothing but a performance test with sudden increase of load. Let's say again, if we take the e-commerce e-commerce application. So during the sale season, nowadays you are seeing in the sale itself they are putting some flash sale. Suddenly they will at 9 o'clock there will be giving flat 90% discount. At that time, let's say in normal hours, let's say if we are having some 1000 users on the system, suddenly they announce at 10 o'clock there is a flash sale with 90% flat, 90% discount. So all of a sudden, at exactly at 9 o'clock, like if they announce at 9 o'clock, suddenly at 9 o'clock we will see a huge spike on the system. On an average load will be 100 users, 1000 users, and suddenly at the sale flash sale time, the user will be double, triple, 10 times sometimes. Like suddenly it will go to 10,000 also. Nowadays these type of flash sales are very frequently we are seeing, right? So those cases, we'll do spike testing. Okay, these are the four important types under performance testing. And we have another type, volume testing. Like in very few companies they will do the volume testing is nothing but before doing the load test, right, they will insert huge number of records in the database, and then they will do testing. Like let's say if they inserted thousands, millions, billions of record, um, let's take a banking application, like they insert millions of records related to loans, and then they will do a loan search. If there are a huge amount of data was inserted in database, then how application is responding. Let's say if they do a loan search, and if the million billion of records are there in the database, how fast it is displaying the loan information. uh, this type is known as volume testing. Okay, but in very few companies they will do, but just heads up, just I'm getting that. And let's move to few performance, do you have any questions in this load testing, stress testing, soak testing, spike testing?
Ganesh, I do.
Yes, please. Yeah.
Yes, I have one question. Here, the transaction what you're speaking about, the
Yeah.
transaction is considered to be user action, any user action, or it has to be
Yes.
only one individual booking one ticket.
No, transaction refers in performance testing terminology. Transaction referred as a single user action. Let's say uh, let's take a simple example, and we will take the same example yesterday we discussed, right? Accessing the home page, it's nothing but launching application. It's a nothing but a one transaction. Okay, then we will do a login. Login is nothing but one transaction, and then we will do a search, product search. Product search is one transaction. In performance testing, each click, we can say it as a transaction, and when we measure the response time also, we will measure the response time in terms of uh, each click we will consider as a one transaction, and for each transaction we will measure the response time.
Yeah. Thank you, Ganesh.
Is it your question cleared, or
Yes, Ganesh, it's clear. Thank you.
okay? Any other question? Okay. Let's move to performance testing terminologies. Okay. Yesterday we discussed about, like in yesterday class, like I used the term called performance bottlenecks, like twice or thrice I used this bottleneck terminology, and I think Ajay asked some question about this bottleneck. So, okay, so I'm putting some definition, and I will try to elaborate a few performance testing terminologies. Okay, the transaction is one of just now someone asked the what is mean by transaction. Transaction is also one of the terminology, like in performance testing terminology. Each click we can consider as a each click or each user action we can consider it as a transaction. Okay, let's start with this performance bottleneck. Okay, uh, any software application does not met the user expectation. Let's say um, I'm accessing Amazon website. Uh, Usually, like we'll get the once we hit the Amazon.com in the browser, Amazon.in the browser, and once you hit the enter button, immediately in fraction of seconds, like sometimes maybe we can say less than 1 second, we are seeing the Amazon website was launched. Okay, so um, our expectation is like within one, let's take it as a 2 seconds. Within 2 seconds the Amazon website should launch. Okay, that is our expectation. Okay, if it is taking 10 to 15 seconds, it's not meeting it's not meeting our expectation, right? We can say this is a bottleneck for that application. Okay, then you place order to get a confirm SMS, right? Once we place the order, we will get a confirm SMS, confirmation SMS. If you are not receiving that SMS within 2 to 3 minutes, it is taking some 1 hour. It's not meeting the user expectation, right? So no one will wait till 1 or 2 hours to get the confirmation message. So like this, anything which is not meeting the user expectation or SLAs, we can say that as a bottleneck in any software application. Doesn't met the user expectation. Here user expectation includes lot of things. One thing is response time. Response time is nothing but uh, how quick the uh, I can how quick it is giving the response. Like response is nothing but if we click on a login button, it should log into the application, right? How much time it will taking to log into the application is nothing but a response time. Okay, in next slides we will I will clearly explain you response time. Throughput is nothing but transactions per hour, and availability, application availability. All this comes under user expectation. And another term called like SLA. SLA is service level agreement. When client come up with any non-functional requirements to the performance testing team, in the definitely there is one term called SLA. SLA is nothing but service level agreement. It includes like acceptable response time, resource utilizations like CPU percentage, memory utilization percentage, heap utilization percentage. There are other lot of things we'll have in that NFR, like we'll detailedly see in the next subsequent sessions. Okay, we can call them as performance bottlenecks. Bottleneck can be anything. sometimes due to poor hardware configurations, like if application is not performing well, there could be a lot of reasons. If the CPU memory is not good for the server, like not expected, like let's say um, I think most of you already aware, right? If you are using 2 GB RAM system and we are installing Oracle software and trying to do some stuff, right? It will be a little bit slow. If you use 4 GB RAM machine, so it was somewhat better. If you use 8 GB, it will be like give the better performance. Okay, so these all are hardware resources, right? The performance bottleneck can be anything such as hardware resource limits and software resource limit. Sometimes like if you're using some outdated versions of softwares, that could be one of the reason. And if any configuration settings at server level, um, uh, we have web servers, application servers, DB servers, right? If the operations team or who are taking care of these server related things, right, if they not properly done any configuration settings, that could be also one of the reason. And if the DB person, if not written the DB queries in proper format, and if they are not optimized, uh, that could be also one of the reason. And if developer wrote very poor code, right, that could be also one of the reason. And few applications use the third party services. Let's say uh, if you are doing if you are placing any order, right, while doing the payment, it will redirect to the payment gateway, third party payment gateway server, and they uh, payment was done, and after that again, once payment was successful, it will again redirect to the our actual e-commerce website. So if there is any issue with the third party service, then payment might fail. That is also one of the bottleneck, but the bottleneck is in the third party service. Okay. um, this is all about performance bottleneck. Then we'll discuss about what is concurrent users and simultaneous users. So during this course, we will use these terms. Uh, uh, Concurrent users and simultaneous users are not same. They are different. Okay, let's see what exactly the concurrent users means and what exactly the simultaneous users means. So uh, number of users, here also I'm taking the same example here. Launch application, login, search product, and logout. Okay, these are the 4 transactions, means 4 user actions. Okay, number of users accessing the application over a period of time is known as concurrent users. So um, for any business scenario, like this is a business scenario, business scenario is nothing but product searching business scenario. In this business scenario, what are steps are there, transactions are there: launch application, login application, and product search, then followed by logout. So here we have a requirement, like we need to test this application with 4 users. Okay, four concurrent users. So 4 concurrent users means the first user might do a launch application. By that time already second user done the launch, and he is doing login, and third user is doing product search, fourth user is doing logout. The fourth user is doing logout means by the time already he done launch, login, search product, and finally is doing logout. If you see, um, each user is performing different action, not same action. Okay, so these users we can call it as concurrent users. Let me take you to see. I will use this example here. There are 4 persons: John, Vicky, Jack, and Ken. Okay, so here John is performing ticket availability, so he's taking tickets availability functionality. Vicky is doing ticket booking. Jack is doing cancel ticket. Ken is doing ticket status, checking ticket status. Okay, so we can say these 4 users as concurrent users. Is it clear, everyone?
Yes, guys.
All these 4 users are accessing the application but performing different user actions concurrently. Okay, so we call these users as concurrent users. So when it comes to simultaneous users, what simultaneous users means? So this John is performing ticket checking availability. Again, Vicky also checking ticket checking available tickets availability. Jack is also doing the ticket availability. Ken is also doing ticket availability. So if all the 4 users are doing same user action at any point of time, we call these users as simultaneous users. Is it clear?
Yes, sir.
Okay. If anyone have any doubts, please let me know. I will try to explain one more time. There is no problem in that. So here, see, simultaneous users, number of users performing same transaction together at same time is known as simultaneous users. See, here in this picture, user 1 is performing a launch application, and user 2 is doing search product. User 3 is also doing search product. User 4 is also doing search product. Here, all these 3 users are simultaneous users, not user 1 is simultaneous. Like we can say user 1, 2, 3, 4 are concurrent, but 2, 3, 4 are simultaneously doing a product search. So we can call this user 2, 3, 4 as simultaneous users. I hope it's very clear. So next, coming to throughput. Throughput is nothing but number of transactions per second an application can handle is known as throughput. Uh, just now I told you, right? One requirement, like at the beginning of the session, the client come up with a requirement, right? 100 users need to achieve 1000 transactions per hour. Okay, that is nothing but one requirement. The 1000 transaction per hour means in 1 hour he need to do 1000 ticket bookings. That means uh, here if they give transaction per hour, we can convert that to easily to transaction per hour per second. It's nothing but we can simply do 1000 by 3600 seconds. In 1 hour we have 3600 seconds, right? So if you want transactions per hour, just you can simply divide that transactions per hour by 3600. We'll get the transactions per hour, TPS. The number of transactions per second an application can handle is known as throughput. Okay, and next we will discuss about response time. Response time is the total time it takes from when a user makes a request until they receive a response. It is known as uh, response time, and also we can call it as round trip time. Okay, um, let me open a. Okay, see, just I clicked on one URL, and it takes some fraction of seconds to launch this page, right? So after clicking on enter, right, it will the request go to server and process the request and came back to it will display the this application page. So this time we will call as response time. Let me click on some link here. I click on sorry, it is it is displaying some I click on register. See, after clicking register link, it is doing some processing, right? So request is going to server and the server is giving this sign up page. So we'll call this time as response time. Okay, let me show you here clearly. And latency is the request travel time from client to the server, and server to the client is known as latency. We can call this latency is also known as network latency or network delay. Uh, for better understanding, I will show some pictorial representation. So this is the client. Client is nothing but from where we are um, sending the request. We can say it's our browser. Okay, and this is the backend, which is nothing but the server. So I sent a request, like I clicked on some application launch. So request sent to the server. So it took 2 seconds. Whenever I click access any URL, it should send some request from browser to the server. Let's assume it took 2 seconds. Okay. After the request was received by the server process the request. It will try to understand the request and it will process. Okay. Let's assume it took 4 seconds. Okay. Once the processing was done, server send the response back to the client. Let's assume a response for application launch. It's taking 3 seconds. Okay. To send the request, it took 2 seconds. Processing the server took 4 seconds. Sending the response, it took 3 seconds. Okay. So see here, I give a formula. Latency is nothing but request travel time from client to server. So it took, in our example, a request sent to the server, it took 2 seconds. Okay, plus response travel time from server to the client, it took 3 seconds. Okay, so latency is nothing but sum of these two. 2 plus 3 is 5 seconds. When it comes to response time is sum of latency and server processing time. So 2 plus 4 plus 3, it will give like total 9 seconds. Latency is 5 seconds and server processing time is, sorry, latency is 5 seconds and server processing time is 4 seconds. Total response time, we can say it as 9 seconds. Anyone have any questions on this response time latency, or is it clear? Guys, please respond. Otherwise I can't understand like whether you guys got the understanding or not.
It's clear, Ganesh. It's clear.
Okay.
Thanks.
Okay. Okay. Let's move to next slide. Think time. So think time, we can define it as delay between two transactions. Two transaction means two user actions. Let's say um, I opened any e-commerce site. Let's take Flipkart. Okay. Once I entered the flipkart.com, it will launch the Flipkart application. Okay. After launching the Flipkart application, uh, there will be some time gap, right? At least like 1 or 2 seconds time gap to log in. After login, I will give username, password, and click on login. After login, usually what we will search for any product, whatever the product we want to buy, right? Let's say I want to buy a book. So just whatever the type of book I need, just I will type there. After login and searching the product, there will be some time gap. We are humans, right? Not robots. Definitely, uh, we'll wait for at least 1 or 2 seconds. Minimum of minimum, we will wait 1 to 2 seconds. Sometimes it will be 10 seconds, 15 seconds, depends upon the user. Okay. After product book search, we'll click on the product and then we will add to cart. Then we will do checkout, payment. For each and every user action, definitely a real user definitely wait for some time. So that time we will call it as a think time, because when we develop the automation scripts and simply if we replay, uh, the the request will be sent to the server back to back without very, we can say it's very minimal. So if you send the request in back to back, server can't handle those requests. So to simulate the real users in the sense we all are real users, right? To simulate the real production behavior, to mimic the production like conditions, we will uh, implement the think time concept in automation scripts. So the delay between two transactions, we can say it as think time. And next, moving to pacing. Pacing is delay between two iterations. Here, iteration in the sense, um, let's say, if I asked you to, if I asked anyone to book 10 products, but my requirement is you need to book um, 10 mobile phones sequentially. Okay, I need like in each my requirement is to book 10 mobile phones. Okay. In 10 minutes, my requirement is in 10 minutes you need to book 10 mobile phones. Okay, that means in every 1 minute you need to book one mobile, right? So let's say I can book my mobile phone within 30 to 40 seconds. Let's assume I can book I launch the application, search for Samsung mobile, add to cart, checkout, payment, that's it. Order booked, and all this process is completed in 40 seconds. Let's assume it's not possible, but let's assume I'm able to book the product in 40 seconds. And uh, again, if I go, I started booking a next mobile. So my requirement is to like to book the mobile phones, 10 mobile phones in 10 minutes, right? Again, I booked another mobile phone in next 40 seconds. Like that, I booked all the 10 mobile phones. So what will be time in if I'm booking 10 into 40. So in 400 seconds, I booked all the 10 mobile phones. But is my requirement satisfied here? No, right? Because I need to book 10 mobile phones in 600 seconds. 10 minutes means 600 seconds, right? Instead of that, what I done? I done like I booked all the 10 mobile phones in 400 seconds. So it didn't met my requirement. So to meet the requirement, what I need to do? So if I'm able to book one mobile phone in 10 seconds, I need to 40 seconds. I need to wait 20 seconds, and then I will start booking of other mobile phone. Okay. So uh, these 20 seconds we can call it as pacing time. So delay between two iterations. So after completion of first iteration, we need to wait 20 seconds, and then only we need to start the booking of second mobile phone. Those that time gap we can call it as think time. Pacing. Is it clear? Difference between think time and pacing? If you have any questions, I can repeat one more time. I will try to put a few more examples.
It's clear, sir.
Okay.
It's
So
clear,
then
Ganesh.
we'll then we'll move to ramp up. Ramp up is nothing but the time during which load is gradually increased on the application. Let's say my requirement is let's take some other requirement, again product booking requirement. we need to test a product booking business scenario with 1,000 users. See, if all the 1,000 users log into the application at the same time, it's not a realistic behavior. Even if you see, if any sales start also, right? Not all users log in at same point of time, right? It's not a realistic behavior. So what we will do when we are doing the load testing, um, so this horizontal line represents the time and vertical line represent the users. Okay, if all the 1,000 users are log into the application at same time, the graph it looks like something like this. And it's not a proper way of doing performance testing, because if we do like this, right, if all the load come to system at same time, server is not able to handle all the requests at same time. So uh, even we need to simulate the production like scenario, right? So what we will do, let's say we need to test application with 1,000 users, right? Slowly we will increase the load. So every 1 second, one user will be logged into the application, so that it will be like something. It will take some 10 to 15 minutes. All users will log into the application. Then we'll go with the steady state like this. Sorry, this is for 1 hour, and later. Uh, all the users slowly, after all the users booking the products, they will slowly log out from the application. This is how we will call this as a ramp up, and this is called this is called ramp up, and this straight line indicates steady state, and this indicates ramp down. So the time during which load is gradually increasing on application. So users are slowly log into the application. Every 1 minute, some 10 users are logging slowly like that. In second minute, again some 10 users will log in. Third minute, again some 20 to 30 users log in. In fourth minute, again few users log in. At some point of time, all the users log into the application, and they will start performing product booking. And they start performing product booking for next 1 hour continuously. That is nothing but our load test, right? That's what we are trying to do. So that continuous 1 hour product booking, that we will say it as steady state. After 1 hour, slowly 10 users will log out. After 1 minute, again some 10 to 20 users log out from application. So the time during which load is gradually decreasing from application is known as ramp down. And steady state at we already discussed, right? A point in the time from load will be steady on the application. At some point of time, all the 1,000 users log into the application, and after that continuously they are trying to book the products. That steady state, we will call that time period as 1 hour time period, we will call it as steady state. Most of the organizations, like uh, they will follow, like they will have different requirements. Few companies, the client ask the reports for only steady state. They won't bother about the ramp up and ramp down. Steady state 1 hour. If we run for duration test, if we run duration test 4 hours or 8 hours or 12 hours, they will give the report only for that steady state only. Okay, how to take the how to filter the steady state of these response times, all we will detailedly see in the subsequent sessions. Okay, so ramp up, ramp down, and steady state. I hope it's clear. If you have any questions, let me know. Okay, next other terminologies are average transaction response time and 90th percentile transaction response time. Okay. um, okay, so uh, when we do load test, right, what we will do continuously, we will putting the load on the system and measuring the response times. Let's say again we will take the same example: launch application, login, search product, logout. Okay, so if this scenario we are doing load test with uh, 4 users, and we need to achieve 40 transactions per hour. In the sense, in 1 hour, these 4 users will do application launch 40 times, login 40 times, search product 40 times, and logout 40 times. So when each user is performing each action, right, at end of the load test, we'll get a results, right. Launch application 40 times is nothing but application launch was done 40 times. 40 times in the sense, we'll get 40 response times, right. First time first user hit the application launch, it might take 2 seconds. Let me put here. So first, when user is trying to launch the application, we'll get response time 2 seconds. Okay. Next, when second user is trying to launch the application, it may get 3 seconds. Next, third time, like when first third user is doing, we'll get 1 second. When fourth user is trying to access the application, it may get 2 seconds. Okay, when again so see, during the load test, right, first user will do all this launch, login, search product, logout. After again, first user will do second iteration, right. So again in second iteration, we may get 2 seconds for launch. Second user second iteration, we may get 3 seconds. Like this, we are getting different response times. Okay, for the time being, we'll see these are the um, 10 response times we captured. Okay, if you do a load test, and these are the if we are hitting the application launch 10 times, these are the 10 response times we got. Okay, so average transaction response time is nothing but we need to do average of all these response times. First, we need to do the addition for all these response times, and how many numbers we have, how many times. This is 10, right? So 2 plus 3 plus 1 plus 2 plus 2 plus 3 plus 4 plus 2 plus 2 equal to 26. And how many numbers we have, how many times we hit? 10 times, right? So equal, sorry guys, let me open Excel. I think it will be better if you can explain you better in the Excel. happened? Okay, the Excel is not working properly. Let me show you in the calculator only. So guys, don't bother about this thing. All these calculations was taken care by the automation tool itself. Okay, just to give you the background about what exactly average transaction response time and what exactly 90th percentile. I'm showing what is the background work done by the automation tool. Just I'm trying to show you. Okay, average transaction response time is if you hit the launch page for 10 times, each time you will get respect to response time, and we need to add those response times plus 1 plus 2 plus 4 5 plus 2 equal to 24, and we need to divide this by 10, which is nothing but 2.4. So here the average transaction response time is 2.4 seconds. Okay, so this is called average transaction response time. When it comes to 90th percentile response time, what we need to do is we need to arrange these response times in increasing order. So it will be 1, 2, next 2, 2, 1, 2, 2. There is another 2, 2. How many twos are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Next we will 3, 1, 2, 2 3s are there. How many 4s? 1 4 we have, and 5. Okay. I sorted in ascending order. All the response times were sorted in ascending order. Okay. And here 90th percentile is nothing but 90th position of the transaction response time. So we have 10 times, right? The response times for all the 10 transactions, 10 clicks of launch. So in these 10 times, we will ignore last 10%. In this last 10%, in out of 10, 10% is we need to ignore the last value. So this is the last value, right? So we need to ignore these 5, and here 4 is nothing but 90th percentile response time. Is it clear? The difference between average transaction response time and 90th percentile response time.
Yes, sir.
Okay. So our next topics will be like performance testing life cycle. I think we'll cover this topic tomorrow session. Any questions, guys? What are the topics we discussed today? Do you have any questions? Let me know.